All right, today we're solving rational equations. And if I gave you this proportion problem, solving for x, 3/5 equals x fifths. Now, some of you know how to solve proportion problems already, which is you can do that cross multiplying, right? 5 times x is 5x equals, and then multiply our other diagonal, 3 times 5 is 15, and dividing by 5, we can get x equals 3. Okay, and this is true, you can cross multiply, and part of what we're going to learn today is the reason you can cross multiply. But this problem, of course, can be solved much, much easier. Right? If we just analyze our problem to begin with, 3/5 equals x fifths. How many fifths equals 3/5? Well, hopefully it's obvious that it has to be 3. Right? 3/5 equals 3/5, therefore x has to be 3. And we can use this idea that if our denominator, our fraction sizes are the same size, that essentially we can kind of ignore the denominators and solve the equation up top, which is basically already solved for us here, 3 equals x or x equals 3. And that's the idea that's going to help us solve some more complicated problems. If all of the denominators of the equation are equal, like they were here, and then the equation of the numerators, that's the top, contains all possible solutions, excluding the set of restricted values. So that means if there were, some domain restrictions that we had to exclude, we have to make sure that we don't have a conflicting answer that makes our function undefined or equation undefined. So here are some steps. We're going to find the least common denominator and make any non-fractions into fractions by placing them over 1. So find a common denominator so we can make all the denominators equal. And of course, using our least common denominator, make equivalent fractions. And in this step, we'll go ahead and multiply or distribute things together. Write any domain restrictions from our least common denominator, so anything that makes the denominator 0. And we kind of want to just make them stand out. So circle, highlight, or box them in some way. Step 4 is ignore the now matching denominators, kind of like we could ignore these 5s, and solve the equation in the numerators. In this case, 3 equals x. Didn't require any extra steps. Okay, check our solutions though with any restricted values and make sure to throw out any conflicting answers there. Okay, so here's our first equation. Notice, lucky for us, everything is a fraction. Now we can't cross multiply here because we have 2 terms on the left. You can only use cross multiplication when it's 1 fraction equals 1 fraction. So you could do some stuff to combine this into 1 fraction like the previous lesson, but we're going to make it simpler than that by finding the least common denominator. So we look at our denominators and none of them factor out, but our least common denominator that we can use, well, we can have 1x, right? We already have a couple that share 1x. Let's put x in our LCD, and we're going to need a 2 as well. Remember, we can't get rid of any extra factors. So our least common denominator we want all of our fractions to have will be 2x. So we should be able to easily manipulate all of these to having a denominator of 2x. So let's look at what we need to multiply them by to get there. Okay, this fraction has the x, but it's missing 2. So we multiply top and bottom by 2. And up top, it says go ahead and multiply in this step. 4 times 2 is 8. Our second fraction has the 2, but it's missing x. So we'll multiply top and bottom by x. And 5 times x gives us 5x. And our last fraction has the x. It doesn't have 2. So we'll go ahead and multiply top and bottom by 2. Negative 11 times 2 is negative 22. Okay, so that was step 1 and step 2. Find the LCD and make our equivalent fractions. Step 3 is to write any domain restrictions. So notice that we do have 2 factors in our LCD, 2 and x. 2 will never be 0, but x could be 0. So we need to say our domain, x cannot equal 0. And either box that in, circle it, make it stand out in some way so we can check versus it towards the end here. Okay, now let's go ahead and we get to essentially ignore the denominators. See you later. Now you only ever do this when we're solving and we've gotten all the denominators to be equal. Okay, don't ever do that when you're simplifying an expression. Never get rid of the denominators like this. But we can go ahead and solve the equation up top. When does 8 plus 5x equal negative 22? So let's move 8 to the other side. We get 5x equals negative 30. And dividing by 5, get x equals negative 6. Now, before I mark that as my final answer, we want to check that versus our domain. And it looks like it is not a restricted value. Negative 6 was not one of our restricted values. And so 6 is our final solution. Sorry, negative 6. Okay, let's try a second example on here before we move on to the next page. Okay, so notice we have subtraction here, which I like to go ahead and change to adding the opposite. So we're going to make that a negative 4. And let's place 4 over 1 to make it a fraction. So as I look at my 3 denominators here, I know I could make them meet at 16x or even 16x squared, but that is not the least common denominator. And I want to use the least common denominator because it's going to give me the easiest equation up top to solve. So in this case, you could actually make them all meet at 8x. And if we put them all over 8x, we need to make our equivalent fractions, figure out what we need to multiply them by to get there. So our first one, notice, already has our common denominator, so we don't need to change that at all. The second one, though, needs both 8 and x. So we really have a negative 4 times 8x. It's negative 32x. And our last one needs to be multiplied by 4 to turn it into 8x. So 5 times 4 gives us 20. So similar to the last problem, we have just 2 factors in our common denominator, 8 and x. 8 will never equal 0, but x might. And so to make sure we don't have division by 0, we will exclude 0 from our domain. X cannot equal 0. That's a 0. Okay, now we'll go ahead and ignore our denominators and then solve the equation of the numerators. So 3 minus 32x equals 20. Let's subtract 3 over negative 32x equals 17. And divide by negative 32. Whew, that's a pretty ugly looking answer. I don't think it reduces at all. So we get negative 17 30-seconds. You can put the negative sign up top, in front of the fraction, or in the bottom, as long as it's just in one of those 3 places. I should have noted as well that we should be checking versus our domain, but of course that was not our only restricted value. It was not 0, so it is a valid solution. Of course, we could plug back in with maybe a calculator or some technology to make sure our answer is correct, but it at least is not a restricted value, which will sometimes help you on those multiple choice problems. You can usually exclude some answers right away. Okay, we have a few more of these to do. So notice in this one, in number 3, again, we have something that's not a fraction. So let's make it a fraction by placing it over 1. And the denominators we're given cannot be factored. So I'm going to put parentheses to show they are their own factors. And in fact, the least common denominator I can have is going to be x minus 2 times 1, which is essentially just x minus 2. So that's the denominator. I want them to all be over x minus 2, okay, which a couple of our fractions already have. But note that one in the middle does not have our common denominator yet. And if you didn't put that over 1, you might forget to change that fraction. Okay, so for this one, we need to multiply it by x minus 2, top and bottom, and go ahead and distribute up top, which gives us 7x minus 14. Okay, here looking at our denominator, the value of x that will make the bottom 0 is positive 2. So we're going to say that x cannot equal 2. And box that in to remember to check our answers against it. Next, we can now ignore the denominator, again, only when we're solving, and try to solve the equation up here in the numerator. This is a 10. Apologies here, guys. my zeros look like 6s today. 5x equals 7x minus 14 plus 10. Let's go ahead and combine those two, which will give me 7x minus 4. And let's move our, say, 7x to the other side, which will give me negative 2x equals negative 4. And if you divide by negative 2, we get x equals 2. So before we box that in, we check with our domain, and wait a second, x can't equal 2 because it would give me division by 0. But this is the only possible answer we came up with. Well, it's an excluded value. X can't equal 2. And because there was only one possible solution, but it can't work for our equation, this actually means we have a no solution problem. You might see this symbol as no solution. You might see the empty set brackets. I can't draw those very well. Also as a no solution, but these are all different ways of saying this problem has no solution. Okay, let's try some more examples, but this is a good reason to check with your domain, right? Because you could have done all your math right and gotten 2, and 2 would probably have been in the multiple choice answers on a multiple choice test, but the correct answer here would be no solution. Okay, let's try number 4. Okay, this one's a little more complicated if we look at all of our denominators, and we do actually need to factor our denominator here. This is a difference of squares, x plus 1, x minus 1. Okay, so I'm just going to kind of get rid of that. That now exists here. This can't be factored out, and don't forget to put that over 1. So our least common denominator here, well, a couple of them have an x plus 1, so let's give our LCD an x plus 1. But let's list everything that's not common. I need an x minus 1. And technically I would also need a 1, but 1 times these things are just those things. Okay, so our LCD is x plus 1 or x minus 1, or you could write it as x squared minus 1. I would prefer to write it this way because it will remind me what we need to multiply by. So let's set up our denominators. Okay, there's all my denominators set up. So let's figure out what we need to multiply each one to get there. Well, my first fraction has just the x plus 1. It needs the x minus 1 top and bottom. And yes, that means we are going to need to kind of FOIL or distribute out the top. So let's do that here. 4x times x is 4x squared. 4x times negative 1, negative 4x. 1 times x, positive 1x. And 1 times negative 1 is negative 1. Okay, note our second fraction already has our common denominator, so that gets to stay the same. But our last fraction doesn't have either one. So here we could actually be kind of smart. You could write in the bottom that we're multiplying x plus 1, x minus 1. Now up top though, if I want to save myself a little bit of time, remember that these two, when multiplied together, look like x squared minus 1. So if we want to save ourselves a little bit of time, we can rewrite it in that form. That gives us a little less multiplying to do. So 3 times x squared is 3x squared. 3 times negative 1 is negative 3. So don't forget here, I need to write my domain. Okay, x cannot be negative 1 or positive 1. Let's make sure to box that in so we can check our answers versus that. Now we can essentially ignore our denominators and solve this equation up top. Well, looking at all these x squareds floating around, I'm pretty sure we have a quadratic. I'm going to go ahead and combine negative 4x and 1x, which gives me negative 3x. And over here, I'm going to write the 3x squared first. 12 minus 3 makes 9, so it's just simplifying some of the numbers up top. So we do have a full quadratic. Let's keep x squared positive. So let's move everything to the left and set this equation equal to 0. So I'll leave in minus 9. Okay. So that ends up giving me x squared minus 3x minus 10. Okay. Equals 0. And I believe this one does factor out. If you do your x factor here, you should get minus 5 and plus 2. Those are the two numbers that multiply to negative 10 and add up to negative 3. Now, setting each one of these equal to 0, we get two possible solutions, positive 5 and negative 2. Now let's check them both versus our domain restriction. Neither one is a restricted value. So what that means is we actually do have two solutions, positive 5 and negative 2. Both of those, if I can box this in, make this equation true. Interesting. Now, sometimes when you get a quadratic like this, one will work and the other doesn't, or sometimes both don't work. Maybe it's a no solution overall. So you do need to kind of check each answer versus your domain. Okay, let's try one last example. Factoring the denominators here. We're going to want to take an x out as a common factor from this first one, and that leaves me with x plus 4. So there's my new denominator factored out. And this one I can't factor. But between the two, my least common denominator, I notice they share an x plus 4. So we'll include one x plus 4. And our one non-common factor, or uncommon factor, x. So there's my least common denominator. So I want them to both have x times x plus 4 in my denominator. Oops, x times x plus 4. And now let's figure out what we need to multiply them by to get there. Well, our first fraction was all set. It's got our common denominator. But our second one has the x plus 4, but it's missing x. So we need to multiply top and bottom by x. So 1 times x, of course, is just x. Now I need to state my domain. So from that x on the outside, x cannot equal 0. And from this factor, x cannot be negative 4. So we have two restricted values. Again, we'll box that in just so it stands out. And now, again, essentially we can ignore the denominator and solve the equation up top, which, look at that, nice and easy. It tells me x equals 3. Right? No extra steps we have to do. It's not a quadratic. We check our solution versus our domain, and it does not appear to have a conflict. So we have our solution. And this problem, if you had done this through, and this was one fraction equals one fraction, if you had done this through cross multiplying, instead, just to show you really fast, you end up having to solve a quadratic. So if I were to cross multiply here, right, so I'm just going to do this problem a second way off to the side here. Distributing times 1 gives me x squared plus 4x equals, and then distributing a 3 here gives me 3x plus 12. Now moving everything to one side to set my quadratic equal to 0. There's nowhere to line up the negative 12, sorry. We get plus x minus 12. If we x factor that, this is x plus 4, x minus 3. And it gives me two possible solutions of negative 4 and positive 3. But if I check those two with my domain, I realize negative 4 is a restricted value. So in fact, only positive 3 is the solution. So note, this was just an example. It's the same problem, just done by cross multiplying because it was one fraction equals one fraction. But you get a much more difficult equation to solve. We had to solve a quadratic here, where here it just basically said 3 equals x, right? So finding the least common denominator is always the quickest way and gives you the easiest equation to solve.